Okay, 4.6, double angle formulas, aka compound angles. So we're going to derive a bunch of the three double angle formulas, and we're going to use the angle addition formulas in order to do that. And so we need to write down, first of all, we're going to look at sine of a plus b, and then we're going to turn it into the sine of b plus b. We're going to say, well, what if those two angles are actually the same angle? Then what does it look like? So we have the sine of a plus b, the angle addition formula for sine. What is it? Who's got it memorized?
It's sine A cos B subtract sine B cos A. All plus cos A.
Lovely. Good. Thanks very much. And so then we say, well, what if A actually equals B? What if they're the same angle? Well, then we end up with the sine of B plus B. And on the right-hand side, we have then the sine of B times the cos of B plus the cos of B times the sine of B. And because multiplication is commutative, sine B times cos B is actually the same as cos B times sine B, and so we have two of those. And so the right side looks like 2 times the sine of B times the cosine of B. And the left side, in the bracket, you have B plus B. Well, that's just 2B. Sine of 2B. So if you see something like this, you have to realize that that angle is being multiplied by 2 before you apply the sine ratio to that angle, okay? So it's the sine of 2b, not the sine of 2 times b, the sine of 2b. And then right side is there. Okay, second one, the addition formula for cosine. Cos of a plus b. What's that one? Cosine of a times cosine of b minus sine of a times the sine of b. Well, what if a and b are the same? What if a equals b? Well, then we have the cosine of b plus b on the left, and on the right, we have the cosine of b times the cosine of b minus the sine of b times the sine of b. Left side is fairly straightforward to understand. That's going to be the cosine of 2b. On the right-hand side,
cos B squared subtract sine B squared.
Yeah, so we're going to square these guys. And in order to write that, again, we apply this, we put the square, the superscript in between, directly following the cosine, just so that we don't confuse it with the cosine of b squared. Okay, and then here we have the sine b squared. Good, good. Last one is the tangent. We have the tangent of a plus b, which is kind of awkward. Draw your line first, and then you have the tangent. In the numerator, you have the tangent of a plus the tangent of b. In the denominator, you have 1 minus tan a tan b. Well, what if a equals b? If they're the same angle, if it's a double angle. Well, then you have tan of b plus b equals, and on the right-hand side, you've got the tan of b plus the tan of b in the numerator. And the denominator is 1 minus the tan of b times the tan of b. To reduce that, on the left-hand side, you're left with the tan of 2b. And on the right-hand side, in the numerator, you have 2 tan b. And the denominator, you have 1 minus the square of the tangent of B. And there are your 3 double angle formulas for primary trigonometric ratios. Again, if you ever end up with a secondary trigonometric ratio in these problems, you're going to flip it first into the primary. Use the reciprocal ratios and carry on from there. So make sure you have these 3 down. This cosine formula actually has 3 expressions. So if you look at just this piece, because of the Pythagorean identity, the cos squared of b, the square of the cosine of b, can be expressed as 1 minus the square of the sine of b. So if you plugged that in for the square of the cosine of b, you would end up with 1 minus sine squared b minus sine squared b. So you'd have 2 minus the square of sine b. Okay? And that is the cosine of 2b could equal that. Well, if you can substitute the square of the cosine of b, if you can sub that out, well, you can also use Pythagorean identity to sub out the sine squared of b. And so the other way to write it, if you were to do that, okay, 2 cosine squared b minus 1. Okay. Should have just started with this and gone from there. But that's okay. There are 2 more expressions of the double angle formula for cosine. Okay, they're on your magic trig sheet, but that's how you get them. It's just an application of the Pythagorean identity. Okay, example 1. Express each expression as a single sine or cosine function. So we have in A 2 times sine of 7b times the cosine of 7b. Okay, well, the angle that we're dealing with is 7b. Don't get too confused. Sometimes you'll think, okay, I have to split that angle into 2 angles. In this case, you don't have to do that. The angle that we're dealing with is 7b. Okay, so what you're looking for is, just off to the side, if I think about it this way, you're looking for 2 times the sine of A times the cosine of A. You're looking for something on your trig identity sheet that looks like that. Can you find that on your trig identity sheet in the double angle formula section? So this is just the right side of your double angle formula for sine. So if you have the 2 times the sine of x times the cos of x, that's just the sine of 2x. It's your double angle formula. So here, the angle that we're dealing with is x. Here, the angle that we're dealing with is 7b. So I can reduce this to the sine of 7b. Nope, nope, nope. 2 times 7b. Oh boy. Sine of 2 times 7b. Okay, because we have the sine of 2 times our angle is 7b. We can reduce this. This is the sine of 14b. Okay, we don't know exactly how to calculate that because we don't know what b is. But we applied our trig identities and formulas. B, it's kind of awkward. In the numerator, we have 2 times the tan of a over 4. In the denominator, we have 1 minus the tan, the square of the tan of a over 4. So the angle that we're dealing with is a over 4. The trig identity that we're going to be dealing with is the double angle of tangent, I'm guessing. So you just copy down the left side, knowing that your angle is a over 4. Well, the left side of my double angle formula for tangent is the tangent of 2 times the angle. The angle is a over 4. So that gives me 2a over 4. Tan of 2a over 4, which gives me the tan of a over 2. If it helps you, you can bracket the angle measurement. You don't need to, but if it helps you to understand or keep it clear, that that is the angle, then you may do that. In example 2, this is one of those, you're given the location of an angle and you're given the value of one of the trig ratios for that angle. So we're going to use the information that is given. We're going to draw a little circle to figure out where the angle is. We are given that it is in between pi over 2 and pi. So here's pi, and here's pi over 2. It's somewhere in quadrant 2. We're told that the sine is 4 over 5. So now I'm applying my primary trig ratios, SOHCAHTOA. And the sine of this angle is 4 over 5. Well, sine is opposite over hypotenuse. So now I can go over to my triangle, and it doesn't really matter where I draw my line, as long as, you know, it'd be nice if it was really accurate. It doesn't have to be super accurate, but the opposite and the hypotenuse is what I know. This is going to be somewhere up here. Okay, the hypotenuse is 5. The opposite side, so when I finish this diagram, I end up making a right angle triangle, which has adjacent opposite hypotenuse. The angle in question is right there. The opposite is 4. And basically, if I know my right triangles, I can use Pythagorean theorem to figure out what the last leg of this is. But if I know my right angle triangles, I know 3, 4, 5 makes a right angle triangle. And because I'm moving to the left of 0, I'm in quadrant 2. I know that cosine is going to be negative. Okay, so here's my 3 sides. And now I can find the value of the sine of 2x. So this work you might not even see that you need to do yet. But if we write down the steps of solving the equation, we're looking for the sine of 2x. We don't know what the angle x is. We just know it's that the sine of it is 4 over 5. So we can draw that diagram. And we know the double angle formula for sine is 2 times the sine of x times the cosine of x. So this is why we needed our little diagram, because now we can easily, from our diagram, determine the sine of x, which is already given to us. So over here we have 2 times the sine of x, which was 4 over 5. But we used our diagram to get the cosine of x, which is adjacent over hypotenuse, so negative 3 over 5. Negative 3 over 5. In this step, I find it easier to keep the negative sign in the numerator, although it doesn't really matter. You just have to remember that you're multiplying 3 factors, one of which is negative. So your final answer is going to be negative. So here we go, numerator times numerator times numerator. We're at negative 12 times 2 is negative 24 over 25. Negative 24 over 25. And that is the exact value of the sine of the double angle 2x. So your first step is really going to be here, apply double angle formula. And then from there, you can draw a diagram to determine cosine of x. And then simplify. Okay, last example, example 3 on the bottom of that page. Just to note, you're going to have to write fairly small, not like teensy tiny, but it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines to the bottom of the page. Okay? So we're told that the cosine of A equals 2/3, and we want to find the cosine of 4A. So we're looking at this cosine of 4a. This is a double angle. Okay, which angle needed to get multiplied by 2 to get 4a? Well, that's 2 times 2a. Okay, so our first step here is to break this into a double angle. And now we want to note that this is also, there's a handful of different ways to do this. Okay, we're just going to do it one way. From here, you could apply the cosine formula for a double angle. Okay, I'm going to go back and separate this now into 2a plus 2a. Okay, so we're going to make it an angle addition. 2a plus 2a. And from there, going to apply angle addition formula. Okay, again, you could apply one of the three versions, one of the three forms of the double angle for cosine. I don't know why we're doing it this way, but this is what we're doing. So now we apply the angle addition formula for cosine, which says that the cosine of x plus x, or a plus a, angle plus the same angle, is the cosine of 2a times the cosine of 2a minus the sine of 2a times the sine of 2a. We're going to simplify that. So you have a squared situation here and a squared situation here. So now we have the cosine of 2a, and that's squared, minus the sine of 2a, and that's squared. Yes, could have written it the other way. Could have written it like how we did before. Cosine squared of 2a minus the sine squared of 2a. But what I want us to see is that now, within this 2a, we can apply the double angle formula. Okay, so we started with 4a. We're able to break that into 2 times 2a. And now we're going to actually break the angle that we have here into another angle addition situation. Okay, it's a double angle formula. So from here, we're going to apply double angle formula for cosine, where now A is the double angle, or the angle being doubled. So inside this bracket, which is still going to get squared once we keep on simplifying it, but inside this bracket, the cosine of 2a becomes 2 times the square of the cos of a minus 1, and that's still squared. That's just inside the bracket. And the next bracket, oh, I have a little for cosine and sine. The sine of 2a reduces to, or expands to, or is replaced by 2 times the sine of a times the cosine of a. And that's still inside that square bracket. It's still getting squared. Well, why did we do that? Well, what was given in our problem? We were already told that the cosine of a is 2 over 3. Okay, so we have the cosine of a, and we could square it to get the square of the cosine of a. So we have those two pieces. We're still missing the sine of a. How do we get the exact value for the sine of a? Well, we've got our same situation here. We can draw a right angle triangle. Okay, cosine. So, ka, toa. Cosine is adjacent over hypotenuse. So let's say we're looking from this angle here. We've got the adjacent is 2, hypotenuse is 3. And in order to do sine, we need the opposite side. So all we're doing here is 3 squared minus 2 squared equals opposite squared. Okay, it's just an application of Pythagorean theorem. So we've got 9 minus 4 equals opposite squared. So opposite then equals radical 5. Right here, radical 5. Well, now we can sub that in for sine of A, and we already have what we need for cosine of A. So here we go. We have 2 times the square of the cos of A. So we're going to put the cosine of A, which we are told is 2 over 3, and we're going to square it, and we have minus 1. That's all inside those square brackets, which are still getting squared. Then in this next group, inside the square brackets, you've got 2 times the sine of A. Sine is opposite over hypotenuse, so we're looking at radical 5 over 3 times the cos of A, which we're told is 2 over 3. And that is all still inside that square bracket. So now we don't have any trig ratios left. We just have numbers, which we can then work through with just basic arithmetic skills, as long as we're doing the right things first, okay? So we have some exponents to deal with. We have to work inside the brackets first, and we'll reduce the bracket using BEDMAS, order of operations, and reduce this bracket, and then we'll be able to combine them through subtraction. So here we go. Dealing with the bracket first. 2 over 3 squared, that's 2 squared over 3 squared. That's 4 over 9. And we can times it by 2 right away. That's 8 over 9. So inside this bracket, you could keep going if you're good at this with mental math. You could have done 8 over 9 minus 1 is negative 1/9. Okay, but we'll get to that. Move over here. In our next bracket, we've got 2 times radical 5. That's 4 radical 5. 4 radical 5 over 9. And that's still going to be squared. We can go to our next step. And again, you can do as many steps at a time as you can, as long as you can do it. So 8 over 9, that's 8/9. That's almost 1 whole. And we're going to take away 1. So we're going to be very slightly in negative land. We're going to be in negative land by 1/9. We're going to have 1/9 squared. Negative 1/9 squared. We'll leave that alone for now. Or we can finish that out even just in the next line. This is the square of the numerator and the denominator. So that gives us negative 1 over 81. Over here, again, you're squaring the numerator and squaring the denominator. So you're squaring every part. Well, 4 squared is 16.
Would it still be negative though?
Well, it's minus the square. If the negative sign was in here.
Square root of 1 over 9.
Oh, yeah, you're right. Good call. Good correction. Good catch. One mistake. Yes, if the negative is inside, then the square is a negative times a negative, which is a positive. Here, we don't have a negative inside, so here we go. We've got 4 squared is 16. 5 squared is 5. Sorry, the radical 5, the root of 5. The square root of 5, if you square it, it's 5. Okay, so we have in the numerator 16 times 5. In the denominator, we've got 81. 16 times 5 is 80. Okay, so we have 80 over 81. So 1/81th minus 80/81ths. Is that how you would say that? 81ths? You end up with negative 79/81ths or 81ths.
I don't think there's a correct term.
It doesn't exist because you shouldn't have to use it. Okay,
Yeah.
good. You did it. We applied an angle addition formula, and we applied a double angle formula. If from here you applied a double angle formula and it worked, great. If it doesn't work, you just say, okay, how else could I possibly do this, and try to go back and do it a different way.
Can't wait for this to show up on the test.
That's the end of 4.6, double angle formulas. Your practice problems
Professor.
are there for you on the next page. And